So in this set of notes or walkthrough, exactly, let me just hide my little panel here. Okay, so this is our parts per million practice. So if I scroll up, right, this is our parts per million practice. So this is page number 51 in your student notebook. And you're going to need your reference table and you're going to need a calculator because we're going to be doing some calculations. On your reference table, let's go to the last page of your reference table, which is table T. I'm not sure why my reference table is not really working here. Let me just open up a new copy of that over here. So I open here, and where were my reference tables? I don't know where my reference tables were. Hold on. Let me just open from my last session here. There we go. Okay. So when we go to our table T in our reference tables, okay, so here we have our concentration calculations, right? And we are going to be looking at the parts per million. And that's going to be the mass of the solute, right? So that's going to be what we're trying to dissolve, divided by the mass of solution. Notice it says, it does not say mass of water. Okay, so if I add a solute to water, I have to add the mass of the solute and the mass of the water at the same time. So I'm going to just make a little arrow over here. So the mass of the solution is going to be the solute in grams plus the mass of the water in grams, because then that's going to be the mass of the total solution. When something dissolves, it doesn't disappear, right? Matter cannot be destroyed. So it's going to still be present. The mass of it is still there. All right, so now let's get practicing. So what is the concentration expressed in parts per million? I have 20 grams, so that's the mass of my solute, right? And that's going to be sugar, in 80 grams of water. Okay, so remember, it's not solution, right? I need to have the mass of the solute divided by the mass of the solution. So I'm going to do my 20 grams divided by, and I'm just going to show it out, 80 plus that 20, right? The 80 grams of water plus the 20 grams of sugar. And now I need to multiply that times a million. On your reference tables, right, you'll see that's 1 with 6 zeros. For the sake of me not writing all those zeros, that's 10 to the power 6, right? There's 6 zeros. So you can multiply by a 1 with 6 zeros, or you can multiply times 10 to the power 6, right? So just to make it less messy and save me from writing all those zeros, I'm going to be writing 10 to the power 6. But just so that you remember, again, 10 to the power 6 is a million, right? So this isn't a percentage, it's parts per million. And let me just go to my answer key, and our answer is going to be 2 times 10 to the power 5. So now your calculator might not have said 2 times 10 to the power 5. Your calculator might have said this. And then you're looking at that going, well, how do I get this really big number? But that's not one of my choices. And you'll notice that this is why we have this expressed in parts per million. So my decimal point would go here, and then that's 1, 2, 3, 4, 5 hops to the right. To the right is a positive exponent. 5 hops, 10 to the power 5. All right. Question 2. What is the concentration in parts per million? And now I have 0.02 grams of sodium phosphate. So that's the mass of my solute, divided by the mass of the solution. I have 1,000 grams of water, right? That's not the solution. I have to add that 0.02, right? So that means I have 1,000.02, and then multiply times a million. And then when I calculate that, that comes out to be A. I think on your calculator, it comes out to be like 19.999, something along those lines. Remember, these are also really close. You got to be really careful. Put the math in your calculator twice, because sometimes when you're multiplying, like with those 6 zeros, like if you're doing like the 6 zeros, sometimes you might do 5, sometimes you might do 7, and that's going to, mess up your answer. So make sure you do it twice in your calculator, get the same number twice. And that's a way of double checking your math. to make sure you're not doing calculator errors. Now, what is the concentration of oxygen in parts per million of a solution that contains 0.008 grams of oxygen? So that's the solute, right? Solutes does not have to be solids. Solutes can be gases. Divided by, now I have 1,000 grams of water. Again, not the solution. I have to add that oxygen mass to the water mass. And that's going to be 1,000.008 times 10 to the power 6. Okay, and then so multiply by 1,000. So then when you answer number 3, that you're going to get 8 parts per million. Parts per million is often used in environmental chemistry to reflect concentrations of different substances in air or in water. Like if you looked up your water quality report from, wherever you get your, whatever county you live in, you can see the parts per million of different contaminants in your water, as well as the parts per million of other things that are not contaminants, like fluoride is not necessarily a contaminant. It's used for strong teeth. Well, not strong teeth, but teeth health. So what is the total mass of solute? Okay, so now this is, I don't know the mass of the solute. I have 1,000 grams of solution, okay, that's key. And I have a concentration of 5 parts per million. So now I have, to set up, I have my parts per million is 5 equals the mass of the solute, which is what I do not know, so that is X, divided by the mass of the solution, which is 1,000 grams. And now I have to multiply that whole thing times 1,000,000. 1, 2, 3, 4, 5, 6. Right, I'm going to use the 6 zeros instead. Okay, well, most kids get to this part and they're just totally fine. And sometimes they get a little bit hung up on the algebra here. What I like to do is I like to get rid of this 1,000,000. And then I can easily just have X over 1,000, and then I know what to do with that. So I'm going to divide by 1,000,000. 1, 2, 3, 4, 5, 6, right? Gets rid of that 1,000,000. Now I'm going to do that over here. And then I have the 1, 2, 3, 4, 5, 6. So because basically this is now saying what it is, right? 5 parts per million is 5 out of every million particles, right? Just like if I said 5%, that would be 5 out of 100. So now I can cross multiply because that's what I love to do, right? So I have 1,000,000, 1, 2, 3, 4, 5, 6. I have 1,000,000 X, and now that equals 5 times 1,000. So 5 times 1,000. And now get rid of 1,000,000. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now I have 5 times 1,000 divided by the 1,000,000. And my answer to number 4 is 0.005. Okay, I'm sure there's more than one way to do that mathematically. If you did it a different way, that's okay as well. If Mrs. Mitiga does it a different way, that's fine. You can do it that way. You can do it this way. There's a lot of different ways that you can go about solving math problems. But make sure that if a question does ask you to show your work, that you do show your work, because sometimes we just are looking for whether or not you have the correct numerical setup. Number 5, 2,400 gram sample of an aqueous solution. Okay, so then here's my mass of the solution, not water, right? You got to make sure you're reading this carefully. So then that's my mass of solution. And I have the mass of the solute right here, because that's the ammonia, right? Because that's what's being dissolved. And what is the concentration in parts per million? So I'm going to take my 0.012, and I'm going to divide by the mass of the solution. So that's 2,400, and multiply that times 1,000,000. And then my answer is going to be 5 parts per million. All right, so hopefully you're getting the hang of this by now. All right, so now which type of concentration is calculated when the grams of the solute is divided by the grams of the solution and the result is multiplied by 1,000,000? Well, this is where you're really just going to take a peek over there at table T and your reference table, and that is parts per million. Molarity is equal to moles over liters. Percent by mass is a percentage. It's not even a million. A percentage is times 100. And percent by volume, again, that's a percentage out of 100, not out of million. All right, number 7. All right, what is the concentration expressed in parts per million I have 15 grams of potassium nitrate and 65 grams of water, okay, not solution. So that means I have to add the solute mass, which is the potassium nitrate, to that mass of water. So when I do my math, I have 15 grams of my solute divided by the mass of the solution, which is going to be the 65 grams of water plus my 15 grams and then times a million, right? 1 with 6 zeros, right? Or 10 to the power 6. And the answer for number 7 is going to be A. I did the math ahead, so you don't have to watch me typing into my calculator. All right, so what is the concentration expressed in parts per million of a solution containing 5 grams of ammonium chloride and 95 grams of water? So that means I need to, if it says water, it means I have to add those two numbers together. So I have 5.0 grams and of my solute, and now divided by the mass of the solution, which is going to be the 95 grams that I have of water, plus the 5 grams of the solute that I added to the water, and then now times a million. And so the answer then to number 8 is A as well. Yep, just wanted to double check that I had the two, that both were the same, because I have my handy dandy answer key over here next to me. All right, so what is the concentration expressed in parts per million of a solution containing 30 grams of sodium nitrate? So that's my solute, right, 30 grams. So the mass of the solute is 30 grams, divided by the mass of the solution. It's 70 grams of water. So what do we have to do when we see water? We have to add the solute and solvent mass together. So I have the 70 grams plus those 30 grams, and then now times a million. And so then the answer to number 9 is C. And again, you're probably going to get something in your calculator that's not expressed in scientific notation. So, right, 3 times 10 to the power 5 is 3 with 5 zeros, right? 1, 2, 3, 4, 5 zeros. So how do I go from this to scientific notation? This is a quick review. You got to make a number between 1 and 10. So I'm going to put the decimal point here, 3.0. And now I have to figure out where is the end of this large number. So I got to figure out how many hops from here to here. So that's 1, 2, 3, 4, 5 hops. So that's 3.0 times 10 to the power 5. And it's a positive 5 because I hopped to the right. If you hop to the left, you get yourself a negative exponent. All right, if I have 0.025 grams of lead nitrate is dissolved in 100 grams of water, all right, so then that water's H2O is telling me that I have to add those two masses together. What is the concentration in parts per million? So my mass of the solute is the lead nitrate mass, so that's 0.025 grams, divided by the mass of the solution. So I have 100 grams plus that 0.025, so that means I have 100.025. Make it up, and then multiply times a million, which is 1 with 6 zeros after it, or times 10 to the power 6. If you want to enter that in your calculator, you can do that too. And then your answer for number 10 is going to be C. And that sums up our parts per million practice. Make sure, again, check your math, put the numbers in your calculator more than once. And then until our next video, I will see you later.